Alright, Common Core Algebra 2. So we are going to do a flipped lesson here, 4.6, about what are called complex numbers, or you'll also sometimes hear them also referred to as imaginary numbers. Okay, so imaginary numbers are going to have to do with a very special number, which we refer to as I, and I is going to have a specific value that we're going to use. So you can kind of think of I as like we've talked about pi in the past. It's similar to that, but it's going to have to do with square roots. So we're going to identify and define complex numbers and their parts that are important, and then we'll talk about how we add or subtract complex numbers, and finally today we're going to talk about how we multiply complex numbers. Okay, so first thing, a complex number is any number that is composed of what is called a real and an imaginary part. And so composed are going to be like added or subtracted together. So we're going to have two parts when we talk about a complex number. The real number is one part of it, and that is any number we've discussed. So you can think about that as like numbers like 5, -6, any fractions like 1/3, decimals like 0.67. You could think of pi is actually a real number. Okay, any of those we could include square roots too, like the square root of 2 or the square root of 3. Any of those. Those are all real numbers. Now the imaginary number, this is where the I value comes in. So if we have any number containing the value I, then we have an imaginary number. So we could say things like 6i is an imaginary number. We could say -32i is an imaginary number. We could have I times the square root of 7. That would be an imaginary number. We could have fractions. Any of those are imaginary numbers. Now, so the obvious difference here is that we have that value of I. Well, the value of I means the square root of -1. And so this, even though we're always going to write it as 6i, actually means 6 times the square root of -1. Okay, right here, this actually means the square root of -1 times the square root of 7, which you would rewrite as the square root of -7. Okay, now we're going to keep things in a more simplified form, I times the square root of 7. But that's what that negative sign right there means. Anytime we have a negative under a square root, we can pull it out and rewrite it as I. Okay, now, more importantly, if I is the square root of -1, that tells us that I squared would be the square root of -1 squared, or more simplified, I squared is just -1, because that square root and that square cancel out. And so I squared is -1. And as we increase our degrees, we're going to get some different values. We would have I cubed is another important one. That's going to give us a negative I, actually. And then I to the 4th, the last one that's really important, is actually going to be just 1. So we've got 4 different values that are important. We have I squared, I cubed, and I to the 4th. And then any degree higher than 4, we could split into one of these 4 forms. So we'd have the square root of -1, -1, -I, or just 1. Okay, and we'll get more into that in class in a little bit. Most important piece is that you remember I is the square root of -1, and more importantly, I squared is actually -1. Okay, so adding and subtracting complex numbers, we're going to treat those i's just like they're variables right now. So if we had like, what I mean by that is, if we said something like 2x plus 3, well, we couldn't simplify that at all. We'd have to leave it as 2x plus 3. But if I said 2x plus 3x, now we could combine those and we'd get 5x. Okay, it'd be the same idea when we're subtracting. So we have an example here where we're adding, we can only combine like terms, just like we could up here with the 2x plus 3x. So we're going to do 4 plus 7, and that'll give us 11. And then 3i plus a -9i is going to give us a -6i. So this is as simplified as we could get. We could not combine those because one has an I, one does not, and that I kind of behaves like a variable in this case. Hey, subtracting is the same idea. You just need to make sure that this subtraction symbol applies to both of these terms. So combine like terms again. 15 minus 3 is going to give us 12, and then 2i minus a -7i actually gives us a positive 9i. Okay, check that in your calculators if you're not sure. 2i minus a -7. And again, this is as simplified as we could get. Okay, multiplying is going to be basically the same idea. We still want to treat it like a variable, except when I has an exponent. So that's the important piece, when I has an exponent. Here we would just distribute like we have been doing for years now. So 4i times 3 is going to give us 12i plus 4i times 7i. Well, the 4 times 7 gives us 28, and then just like a variable, if it would x times x, we'd have x squared. This gives us I squared. And so here is the piece where we need to be careful, because I now has an exponent, and we talked earlier that I squared is equal to -1. So this actually says 12i plus 28 times a -1, because this piece right here is a -1. So now we have 28 times a -1. That's actually equal to 12i minus 28, because 28 times a -1 is a -28. Okay, the last thing I would expect you to do is rewrite this in what is called standard form. So standard form is always going to have your real part first, which is our -28, plus your imaginary part, which is our 12i. So this is what we call standard form, and that's how we're going to write it. -28 plus 12i. Okay, now this one is a little more complicated. Like we've talked about in the past, we need to actually distribute both the 3 and that 2i. So if I take 3 times both of these, I'm going to get a -3 minus 3i. And then if I change my color up here, I'm going to take 2i now times both of these. And so 2i times a -1 gives us minus 2i. And 2i times a -i gives us a minus 2i squared. Okay, and we can combine some things. So I can't do anything with that -3. I'm just going to rewrite that. However, I can combine these two because they both have an I. So -3i minus 2i gives us a -5i. And then, remember, this I squared is like a -1. So I really have a -2 times a -1, which gives us a +2. And you'll see here, now we can combine those two terms. So I end up with a -1, and then we still have that minus 5i. So I end up with a -1 minus 5i. When I multiply those two, that would be it. And you really need to be careful. Big thing here, I squared is -1. That's how we got +2, and then we can combine those like terms. -1 minus 5i. Hey, that is it, Algebra 2, for our lesson on complex numbers. Complex numbers are going to be used a lot when we start to do quadratic formula, which you have seen a little bit in the past. And when you're multiplying them a lot, we're going to simplify out that I squared to be -1, don't forget. Okay, otherwise, treat it just like a variable. See you next time.